So this is actually the second video that I'm making right here. I'm recording it, so please feel free to stop me if you need me, or if you have a question. I could always pause and re-record. So we did this whole worksheet or this whole front side of our notes yesterday. Let's just review a little bit. Yesterday we learned that we could graph a standard form quadratic trinomial equation. Standard form means that it's in order, highest exponent down to smallest, down to the constant. The a, the b, and the c are just numbers. And we're going to need to know that the a is the number in front of the x squared, the b is the number in front of the x, and the c is the number without a variable, okay? And we learned yesterday that when you graph one of these, it produces a U-shaped curve that either opens up or down. And those U-shaped curves, that when we graph them, those are called parabolas, okay? So the a value technically tells us if it opens up or down. So if we didn't write this yesterday, we could say a tells, maybe a in quotations, a tells us if it opens up or down. That's really ugly writing, I apologize. A tells us if it opens up or down. If it's positive, it's going to open up. The parabola is going to open up. If it's negative, the parabola is going to open down. Okay. What else? It also tells us, if wide or narrow. Maybe we'll touch on that today, but if not, definitely tomorrow. Okay. So the A tells us if it opens up or down, if it's wide or narrow. Okay. We started yesterday with the easiest type of parabola, the parent graph, y equals x squared. And yesterday, since we didn't know any tricks at the beginning of the lesson, we just made an xy table and we started plugging in what is 0 squared? 0 squared is 0. What is 1 squared? 1 squared is 1. What's 2 times itself? It's 4. 3 squared is 9. And we could have kept going, 4, 16, 5, 25, and so on and so on. Then we went negative 1 squared. It gave us a positive 1. Negative 2 squared, when you plug it in here, negative 2 to the second power is positive 4. Negative 3 is 9. Negative 3 squared is 9. And we ended up getting these coordinates, and we ended up getting this parabola. And again, I could have gone forever. I could have plugged in a 4 and gotten out a 16. That would have been a coordinate 4, 16. But from the origin, if you go 1, 2, 3, 4, and you go up 16, you're off the graph. So I didn't choose to graph 416, but it is represented because that does cross through the location 416. So the parabola really does exist to the left and to the right forever, even though you don't see it. Does that make sense? Okay. And that's one of the things that we missed yesterday. I was supposed to have talked also about domain and range. Okay. So this parabola right here, when we talk about the domain, I hope we remember that the domain are your x values, okay? So what is the domain of this parabola? The domain really does go to the right forever and to the left forever. So technically the domain is x equals all real numbers, okay? And that is a question that I will ask on the next quiz, on the next test, possibly on the final exam as well, okay? So this is like a free point on those quizzes or tests because the domain of any parabola, it doesn't matter if your parabola is really wide, really narrow, if it's opening up or opening down, any parabola, they're all going to have the domain x equals all real numbers because all those U-shaped curves go to the left and to the right forever. They're just way up there somewhere off the graph or way down there somewhere off the graph. So the domain is always x equals all real numbers. How about the range though? We didn't talk about the range yesterday and we need to. The range are your y values, okay? Does this parabola that continues to go up forever, does it exist at 10? Yes, it does. It's right there. Does it exist at positive 15? Yes, it does. It's up here. Does it exist at negative 10? No, it doesn't. Does it exist at negative 5? No, it doesn't. Where does it start existing? At the y value of 0. So since range are your y values, right? The range of your y values, the up and down, it starts existing at the y value of 0 and above. So how do we say that it starts existing at the y value of 0 and above? As an inequality, we say the range is y is greater than or equal to 0. So those are a couple of things that we missed yesterday, domain and range. And I hope everybody that's was absent yesterday and you're watching this for the first time, I hope you understand how we came up with these coordinates using an input-output table. Yay? Okay, now we just mentioned earlier that the A value tells you if it opens up or down. If it's positive, it opens up. If it's negative, it opens down. But it also tells you if it's wide or narrow. So in this case, the A value is a positive one. That's why it's opening up. If it would have been a negative, it'd be opening down. But more importantly, because the A value is 1, we know that it's exactly this width, which means that any other quadratic equation with the A value of 1 is going to be exactly this width. It can't be wider, it can't be narrower, because the A value determines how wide or how narrow it is. So if the A value is 1, it's going to be exactly this wide. It can't be wider, it can't be narrower. Okay, it has to be exactly this wide, which means that we could use the coordinates 1, 1, 2, 4, 3, 9 as a pattern when A equals 1. Okay, so if we look at this guy down here, the last one that we did yesterday, if you were absent, you don't have it yet, but we graphed it, and from the vertex, because the A value is 1, you could use the pattern 1, 1, 2, 4, 3, 9. Let me just write down that pattern. Because the A value is 1, you could use the pattern 1, 1, 2, 4, 3, 9. What does that mean? That from the vertex, you could go 1 over 1 up, and then you could go back to the vertex 2 over 4 up, back to the vertex 3 over 9 up. And you could get coordinates really easily using the pattern 1, 1, 2, 4, 3, 9. But this pattern only works as of right now when the A value is 1. Tomorrow, I'll teach you how to modify the pattern when you have other different A values. Anyway, back to the original one right here. Again, this is the easiest one. We graphed it with the XY table, but we recognize that if the A value is 1, we're going to be able to use these coordinates as a pattern. So it doesn't matter where your vertex is at. By the way, this is the vertex, if you weren't here yesterday. The vertex is either the highest point or the lowest point of a parabola, depending on if it opens up or down. And how do you determine if it opens up or down? With the A value. If it's positive, it opens up, which means that the vertex is a minimum value. It's the lowest point. Or if it were negative, it would open down, which would mean that the vertex is a maximum point, okay? And that in turn kind of tells you that the range is y is either above that y value of the vertex or below the y value of the vertex. Anyway, it's a lot of stuff we covered yesterday, and I'm just reviewing it right now. So what if you don't have the A value of 1? Tomorrow I'll show you how to modify the pattern, but as of right now, we're going to use an XY table to find more points. But back to this. The most important point of any parabola is the vertex. Once you find this point, the highest or lowest point, once you find that point, you immediately draw an axis of symmetry because that'll provide a reflection. And then you could find more points, maybe with the pattern or maybe with the XY table, and you'll be able to get the entire parabola. So the first and most important thing is to know how to find the vertex. Okay, we said the vertex is the most important coordinate, and down here it tells us the vertex formula, x equals negative b over 2a. So you could get your b value and your a value from the original standard form quadratic trinomial equation, negative b over 2 times a. And you work that out, and that will give you the x value of your vertex. The vertex is a coordinate. You're going to find the x value. Once you have the x value, whatever it is, whatever number it is, you're going to plug it back into the function to find the y value. Then once you have that vertex, you graph that most important point, and then you draw your axis of symmetry right through it. So on this guy, for example, let's just focus in on the original quadratic trinomial function that's in standard form. Step 1 is to find the vertex. You know the vertex is a coordinate. Pretend you don't see these numbers, but you do know the formula, x equals negative b over 2a. So you rewrite the formula, but instead of b and a, you put parentheses, and you plug in the actual b value, which is 6, and the actual a value, which is negative 3, and then you do the math. And negative 6 over 2 times negative 3 is negative 6. Negative 6 divided by negative 6 is positive 1. So x equals positive 1. That is the x value of your vertex. So this x value right here is the x value of your vertex. Okay. Now you need to find the y value. Imagine the 8's not there. How do you find the y value? All you got to do is plug it in to find the y. That's what it says right here. So plug it into what? Plug it into the original. You see, we're going to take that 1 and put it right there and right there. That's why it's rewritten right here with the 1 instead of the x's. And we do the math, and we ended up getting y equals 8. Okay, y equals 8. So we have the vertex. You plot that point. You draw your axis symmetry. I always do a green dotted line right through that vertex. And whenever you want a vertical line, you're going to have to type in or write x equals whatever the x value is, right, that you want it to go through. So the axis symmetry equation visually is this vertical line going right through the vertex, but actually writing the equation would be x equals whatever that x value of the vertex is. So if the x value of the vertex happened to be 3, then your axis symmetry equation would be x equals 3. If the vertex had -1, then your axis symmetry would be x equals -1. But because the vertex is 1, the axis symmetry is x equals 1. Anyway, you want more points? You could go to a input-output table and just plug in some numbers like 0. Plug in 0, you get out 5. By the way, that's another thing that we missed yesterday. Plugging in 0 will give you the y-intercept, okay? So that's something that we should probably write down. The y-intercept is very important. It's the location of where your line will cross the y-axis, and you could clearly see it right there. I just put a yellow dot right there, okay? But let's say you didn't see it. Let's say you only had the equation, and they asked you, find the y-intercept of this. I hope we remember from semester 1, to find the y-intercept of anything, we set x equal to 0 and solve. We set x equal to 0 and solve. So if you take this and set your x's equal to 0, it's going to be a really easy math problem because 0 squared is 0, -3 times 0 is 0, 6 times 0 is 0, 0 plus 0 is 0. Everything cancels out except the c value. So the y-intercept is the x value being 0, plugging it in, doing the math, and getting out the c value of 5. Okay. So just by knowing your y-intercept, by plugging in 0 for x and getting out that 5 for y, you'll know that yellow dot, which is a location of where it crosses your y-axis, and you could map that over to the other side using the axis symmetry, and you already have a great description of what the parabola looks like, right? Of course, if you want more points, just plug in more points on the XY table. But I guess I've covered what I wanted to cover. Yesterday, I forgot to talk about domain and range, and we also forgot to talk about y-intercept. Y-intercept comes in handy. All you got to do is set x equal to 0, which is super easy, especially when they're standard form quadratics, because when you plug in 0 for x, your answer is going to be the c value. So I know my y-intercept is going to be 0, -3. Okay. Anyway, let's reiterate what we learned yesterday before we move on to the backside. Yesterday we learned that to graph an equation, you have to find the vertex. How do you find the vertex? With the formula. That'll give you the x value. How do you find the y value? Plug it back in. You'll find the y value. Now you know your x and y value of that most important point, the vertex, which is either your highest point or your lowest point, your maximum or minimum value of your parabola, depending if it opens up or down. And if it opens up or down, depends on the a value. If it's positive, it opens up. So even without looking at the graph, you know it opens up. You know that that vertex is a minimum value. What you should do is graph it, 0, -3, put a dot there, draw your axis symmetry, and then you want more coordinates. You could either use XY table to find more points, or because the a value is 1, from the vertex, you could go 1 over 1 up, 1, 1, 2, 4, 3, 9, using the pattern, 1 over 1 up. That's not the coordinate 1, 1. It's the pattern from the vertex, 1 over 1 up. And if you're thinking over where, to the right or to the left, it doesn't matter. You need it both ways, right? You could go 1 over this way and 1 up. Go back to the vertex, 2 over this way, 4 up, right? 2, 4, 3, 9, 3 over this way, 9 up. And you can map them over and you'll have your perfect parabola. So how do we graph parabolas? It's this simple. Step 1, find the vertex. Step 2, draw your axis symmetry. Step 3, use the pattern or use some XY tables to find more points. How about the domain and range of this guy? What is the domain of this parabola? It's important to say x equals all real numbers because the domain are your x values, the range are your y values. How about the range of this parabola? Y is what? Y is greater than or equal to what? To -3. Perfect. And you didn't even have to actually graph it. If you know your vertex, once you do the vertex formula and you know your vertex, you know that the vertex is either the highest point or the lowest point. It's either the maximum or minimum, depending on if it opens up or down. So you know it opens up. You know this is a minimum. You know that the y value is -3. So it starts existing at -3, which is a minimum y value. So it has to be above -3. That's why the range is y is greater than or equal to -3. So you could even conclude that without having to graph it and see it. Obviously, graphing it and seeing it is easier. It starts existing at -3, not at -10, not at -5. It starts existing at -3 and above on the y. So how do we say that it's at -3 or above on the y? Y is greater than or equal to -3. Okay, let's flip the paper over. So back here, we actually have some practice I would like you to do. Step one, or not step one, let's just read what it's asking us to do. Practice. Please find the vertex. We know how to do that. Use the vertex formula. Find the axis symmetry. That's just the green dotted vertical line going right through that most important point called the vertex. If you wanted the axis symmetry equation, that'll be x equals whatever the x value of your vertex is. We could also find the y-intercept. How do you find the y-intercept? You set x equal to 0 and solve. And then using your vertex, using your axis symmetry, and using your y-intercept, you could graph it. If you wanted to, you could also use the pattern to get a more detailed parabola if your a value is 1. Stating the domain of any parabola, it doesn't matter if it's up or down, wide or narrow, the domain is always x equals all real numbers, and the range is either above, at or below that maximum or minimum y value, which is a vertex. So without further ado, let's try this first one. Let's start by finding the most important part of a parabola, the vertex. Okay, and the vertex is a coordinate. And how do we find that coordinate? By using the formula. The formula is x equals -b over 2 times a. And when you use this formula, I highly recommend for you to put parentheses instead of the b and parentheses instead of the a. Now, where are we going to get this a and b value, a, b, and c values? Where do we get those at? From the original ax squared bx c. Now keep in mind, sometimes you're not going to have a c value. Sometimes you might not have a b value. But in order for it to be a parabola, you need an x squared, so you're always going to have the a value. Anyway, what is the b value? -2. And what is the a value? There's an invisible 1 right there. So here's our formula. A -2 is a +2. So what we have here is +2 over 2 times 1, that's 2. So 2 over 2, that's really a 1. So what did we just find? We found the x value. The x value of our vertex is 1. Are you with me? We still need the y value. So how do I find the y value if I know that my x is 1? How do I find the y value? I plug it in. I take that x value of 1 and plug it in right there and right there. So I'm going to rewrite this whole thing, but instead of x's, I'm going to put parentheses, and I'm going to plug in the 1 right into those parentheses. So here it is. We have y equals x squared minus 2x minus 1, and I'm plugging in the x value of 1 into the parentheses where the x's used to be at. And now we're going to do the math. When I do 1 squared, that's 1. When I do 2 times 1, that's 2, and we still have a minus sign in front of it. And then we're going to bring down the -1 over here, -1. So y really equals 1 minus 2 minus 1. That will be y equals -2. Y equals -2. That is the y value of your vertex, okay? The x value was right there, it's 1. The y value is up here, it's now -2. That's the hardest part of graphing a parabola, finding that vertex. Let's graph that vertex. Where's the location 1, -2 at? You go from the origin, 1 on the x, -2 on the y, and you put a dot right there. So here's the location 1, -2. What's the very next thing we should do? The very next thing we should do is to state the axis of symmetry. And the equation of the axis of symmetry will be x equals the x value of your vertex. The x value of your vertex is 1, so the equation is x equals 1. It's one thing to state the equation of the axis of symmetry. It's another thing to draw it and use it when you graph. So let's draw it. It's going to be a dotted line going right through that vertex value, vertical dotted line. And now we need more points. So I could, if I wanted to, answer what they ask us up here to find the y-intercept. Let me actually do that real quick. To find the y-intercept, that's going to be a location of where it crosses the y-axis. And to find the y-intercept, you must set x equal to 0 and solve. Okay? So if I plug in a 0 here and a 0 there, well, first of all, if I set x equal to 0, my coordinate's going to be 0 comma something. Let's find that something by plugging in 0 into those x's. 0 squared is 0. 2 times 0 is 0. 0 take away 0 is 0. And 0 minus 1 is a minus 1. So what's my y-intercept? It's 0 comma -1. So you could go to 0, -1 and put a dot there. And knowing that your axis of symmetry provides a reflection to the other side, you might as well just reflect it over to the other side. It's 1 unit away, go 1 unit this way, and put a reflection point right there. And ladies and gentlemen, we already have a good enough idea of our parabola. Even though it's super tiny, we have a good enough idea. If you wanted more points, you could go to a input-output table, XY table, and plug in more numbers, maybe like 3 or like 4, or even easier, you could recognize that the A value is 1. So when the A value is 1, you could use a pattern. When A equals 1, you can use 1, 1, 2, 4, 3, 9 from the origin. Not from the origin, I'm sorry, from the vertex. Let me write that down. From vertex. So here's my vertex. If I go 1, 1, because the A value is 1, I could use this pattern. 1, 1, from the vertex, 1 over, 1 up, boom, I'm at that blue dot. I already knew that though. Let's now go back to the vertex and go 2, 4. From the vertex, 1, 2, up 4. 1, 2, 3, 4. Put a dot right there. And we have more dots now. You could go back to the vertex and go 3, 9. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm 2 units off. You don't have to graph it. I'm just going to put a slight tiny dot up here. That way, when I draw it, I'll know to point towards that dot, but not actually draw it all the way out there. And of course, I'm going to reflect this dot 2 units away from the axis of symmetry. 2 units this way would be right here. So that'd be this dot right there. And of course, if I wanted to, I could take this dot that's 3 units away and go 3 units this way, and I'll be right above right there, which is kind of pointless, but we could at least use it to point our arrow towards it. And there's the perfect parabola right there. Done without a graphing calculator. What else could we answer? What else did we forget? We forgot about domain and range. The domain, x equals what? All real numbers. That's always going to be true no matter what parabola it is. Doesn't matter if it opens up or down, wide or narrow. It's always going to be x equals all real numbers. How about the range? Y is, where is this parabola at in terms of the y? Does it exist at -3? Does it exist at -3 on the y? No, right? Does it exist at -5? No. Where's the parabola at? It's from here up. What is that y value? -2, right? So the range is y has to be at -2 or above. So how do we say that in terms of an inequality? at -2 or above is greater than or equal to -2. And we have stated everything. We found the vertex using the vertex formula. We drew the green dotted line that's vertical right through that vertex. That's the axis of symmetry. We even wrote down the axis of symmetry equation, which is simply x equals the x value of your vertex. There it is, x equals 1. What else? We found the y-intercept. How do you find the y-intercept? You set x equal to 0 and solve, and that'll tell you exactly where your parabola crosses the y-axis. Then you graph it, and then you could reflect it over the other side. And then you could use your pattern if your a value is 1. If your a value is 1, you could use 1, 1, 2, 4, 3, 9. Tomorrow, I'll show you how to modify this pattern in case your a value is 2 or 3 or something else. Okay, let's take a look at number 2 right here. So let's begin by finding the most important point, which is a vertex. Vertex. The vertex is a coordinate. How do we find that coordinate? With the formula, x equals -b over 2 times a. When you use the formula, please put parentheses before plugging in your b and your a. And then you got to look at your function and determine what is a, what is b, what is c. Well, a is always in front of x squared. That means it's a -1. B is always in front of x. And notice there is no x in the middle. There is no bx term. So what does that tell you about b? B is 0. And of course, c is 3, but 3 is not even in the formula, so who cares? But the reality is you need to know that b is 0 because there is no x term in the middle. So that's a 0 right there. And the a value is -1. So you put a -1 right there. And when you do the math, up on top you get -0. On the bottom you get -2. And it doesn't matter, -0, +0. 0 divided by anything is still 0. So x equals 0. You found the x value of your vertex, that's 0. You still need the y value. How do you find the y value? You plug it in. Plug in 0. Where are we going to plug in 0? Into the x. It says x equals 0. There's x. Plug in a 0. So my original equation says y equals -x squared plus 3. I just rewrote it. Y equals negative parentheses squared plus 3, right? -x squared plus 3, negative parentheses squared plus 3. Why do I put parentheses? Because I know what x is. X is 0. So put a 0 right in there. Do the math. 0 squared is 0. With the negative in front is still 0. 0 plus 3 is 3. So y equals 3. So the vertex y value is 3. That's the hard part, guys. Finding this vertex. Once you find the vertex, it's all downhill from there. Let's plot that point 0, 3. 0 on the x, 1, 2, 3 on the y. Put a dot right there. That's the most important point. After that, you could draw your axis of symmetry equation, which happens to be x equals the x value of your vertex, which we know is 0. But drawing it's easier. You just do a dotted line right through that vertex. And that'll provide a reflection on both sides of it, okay? So we just need more points. So if you wanted to, you could use an XY table and start plugging in numbers and pulling out answers. Or you could recognize that because the a value is -1, you could still use the pattern 1, 1, 2, 4, 3, 9, but it's negative, which means it's going down instead of up. So instead of 1 over 1 up, it's going to be 1 over 1 down, okay? Let me write down before I even graph it. Because a equals -1, we could use 1, 1, 2, 4, 3, 9, but opening down. So 1 over 1 down and put a dot there. 2 over 1, 2, 3, 4 down and put a dot there. And then the last one, 3, 9 from the vertex. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. 1 unit off. Who cares? I'll draw it. I'll put my dot right there. And now map them over to the other side, right here, and down here. And then draw your parabola. You don't have to go all the way. You could just put arrows pointing at those that are off the graph. Whoops, that was a little crooked. Let me see. Here we go. And there's your parabola. What about the y-intercept? The y-intercept. What is the location of where this crosses the y-axis? Well, here's the y-axis. You could clearly see that it's the vertex itself, 0, 3. 0, 3. But let's say you didn't know about the, let's say you didn't have the graph. Then you could look at your original equation and simply plug in 0 in there, and you'll get out a 3. So plugging in 0 gives you out a 3, which is still that same location of the y-intercept. Okay. What about the domain? X equals all real numbers. What about the range? Y is what? Anybody? Less than or equal to that vertex y value of 3. Okay. Where does a parabola start existing in terms of y? Well, here's the y, 0, 1, 2, 3. It starts existing here and below. It doesn't exist at 4. It doesn't exist at 5. It starts existing at 3 and below. How do we say that? Y is less than or equal to 3. Okay, guys, so with these examples that we've done, with this review that I did from yesterday, you should be able to do these two right here. And if you try to do number 1, you're going to be, wait a minute, it feels like I already did this one. That's because we did. I accidentally typed in the same one over again. But it's a good idea to try this from scratch. Don't look at the one on the left side. Just do it over again. And you could look at the one on the left in case you get stuck. Okay? And number 2 is very similar to number 2 that we did down here. So that's your practice for today, to do those 2 questions. And that's it. Now, why do I not want you to continue on? Because look down here, we have the a value of 1/2. We have the a value of 2. We have the a value of -3. So you're not going to be able to use the pattern 1, 1, 2, 4, 3, 9 because the a value is not 1. Tomorrow, I'll teach you how to modify this pattern to be able to use it with these other a values, okay? So that's the lesson for today. I hope you guys understand it.